Now let's solve this question given in GATE 2009. This one, the reference string given is 1, 2, 3, 2, 4, 1, 3, 2, 4, 1. This is the reference string given, and the number of frames given is 3. Okay, and now we have to find out the page fault in all the three strategies. Let's start with the optimal. So we have only 3 frames. Somehow in all the GATE questions they have given only 3 frames. I don't know why. I don't know the reason behind it, but in all the GATE questions they continuously ask with 3 frames. It is not that at practice we use only 3 frames. At practice we use lots of frames, not just 3. Now 1 is not there, so load it. 2 is not there, load it. 3 is not there, so load it. And then now we are using optimal. When we are using optimal, whenever there is a miss, what is that we are going to replace? We will be replacing the one which will not be used for the longest. Okay, so now 1 is done, 2 is done, 3 is done. Now we are looking at 2. So 2 is already present, so no need of replacement. And now 4. Now we are looking at 4. So which one do you want to replace? We have to replace one among 1, 2, 3, which will not be referred for a long time. Now see this, 1 is immediately required and next immediately required is 3, but the longest one which is not required is 2. Therefore you can replace the 2. So you can replace 2 with 4. Got it? And next 1 is required, it is there, 3 is required, it is there, and 2 is required. And which one are you going to replace? Now look at the future. So 4 is immediately required, 1 is required next, but 3 is never required. Therefore replace this with 2. And next one is 4 is required, it is there, 1 is required, it is there. Now if you watch it, so how to find out the number of page faults? 1, 2, 3, right? 4, 5. So 5 is the number of page faults. How many references are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So out of 10 references, 5 is the 5. For 5 there is a page fault. Therefore, what is the page fault rate? So page fault rate for this optimal algorithm is 5 by 10, half of it, and hit rate is also 5 by 10, right? Fine. So next one is we shall try with least recently used, LRU. So how are you going to use least recently used? We have to look at the past and then we have to decide it. So in the past, if a page is not being referred, then maybe you can assume that it might not be referred in the future as well. That is the concept behind it. So now 1 is referred, loaded, 2 is referred, loaded, 3 is referred, loaded, and next one which is referred is 2. So when we are referring to, now see the past. Oh, okay, 2 is already available, so you need not do anything. 2 is already there, don't replace it. And next one is 4. Now one of them have to be replaced. Now you look at the past and see which one is least recently used. From 4, if you watch back, 2 is most recently used, 3 is next most recently used, and the last recently used is 1. Therefore 1 has to be replaced with 4. And next one is, that is the problem. In using the past, you have made the decision, you don't know the future, and future is just asking 1 again, right? Now you need the 1. So which one are you going to replace? Again use the same strategy. Look at the past. 4 is not used for a long time, right? And 4 is the most recently used, 2 is the next most recently used, and 3 is the next most recently used. Therefore by looking at the past, you are thinking that since 3 is not used recently, maybe we might need 3 again. We might not need 3 again, and you are going to replace this with 1. Now that is a mistake, isn't it? Future is immediately asking 3. 3 is not there. Then again you do the same thing. What? Look at the past and think which one is not being used for a long time. So if you look at the past, 1 is used, 4 is used, but 2 is not used for a long time. Therefore 2 will be replaced with 3, right? And then immediately 2 is required. Whenever you replace a page, you are getting the requirement, isn't it? Now when you look at 2, now watch it. So 2 is not there. Which one are you going to replace? 3 is recently used, 1 is recently used, 4 is not recently used among the available pages. Therefore you are going to replace it with 2. And next 4 is referred. Now when you look at 4, which one are you going to replace? See, 4 is just now replaced, right? And again you want 4. So if you watch it, 2, 3, 1. 1 is the least recently used, therefore you are going to go for 4. And now 1 is required immediately. Now which one are you going to replace? 3. right? So how many times we have failed here? So 1 2 3 4 5 6 7 8 9. So in LRU the number of page faults are 9, right? And therefore the page fault rate is 9 by 10, 90%, and the hit rate is only 10%, right? Actually this example has been formed in such a way that, if you use LRU, whenever you replace a page, immediately they are asking the same page. Whenever you look at the past and when you replace a page, they formed it in such a way that whatever page you replace, they immediately ask for that. That is the worst case input for LRU. Whenever you are replacing, immediately that is required, right? Okay, and next one is FIFO. Let's see first in first out method and see how it works. First in first out. Okay, so now we are looking at one has to be loaded, 2 has to be loaded, and then 3 will be loaded. And next when we look at 2 is already present, therefore there will be no problem with 2. And when we look at 4, someone has to be replaced, right? So before that, let's maintain a queue. So queue will contain what is the order in which they entered. They entered in the order of 1 2 3, isn't it? So once we have mentioned the order in which they entered, don't modify it depending on the references. Just keep it that way. 1 entered first, 2 entered next, 3 entered next, and I don't care which one is referred in what order. That is what the way in which they entered. Now when I want 4, which one has to be replaced? The one which entered first, which means 1 has to be replaced. 1 has to be replaced with 4, and now 4 is the last one which entered the loop, right? And then now immediately I want 4. So if I want 4, which one should I replace? Sorry, immediately I want 1. So which one should I replace? Now among the available ones, so the one which is which is next, the first one is 2. Therefore 2 has to be replaced. 2 has to be replaced with 1, and 1 will be entering into the queue at the end. Now I need 3. So if I need 3, 3 is already there. That is why it is a hit. And next I need 2. So 2 is again a miss. Which one should I replace? If you watch it, 3 has to be replaced, right? So 3 has to be replaced with 2. 3 has to be replaced with 2, right? And next I need 4. 4 is already there. And next I need 1. 1 is already there. Got it? So in this case, in this example, how many page faults are there for FIFO? For FIFO, the number of page faults are 1, 2, 3, 4, 5, 6. So for this particular example, optimal will always give the best performance, but FIFO is giving better performance compared to LRU. See, depending on the algorithm, the performance will vary. Got it? And in this case, the page fault rate for FIFO for this particular algorithm is 6 by 10, and it varies from for this example is this, and it varies from example to example, right? So anyway, which one is giving least number of least number of page faults? Always optimal. Okay, fine.